This video will give examples on how to model with differential equations. Solve the differential equation, y prime equals 6y, with the initial value of 0. So what we can do here is replace y prime with dy over dx, and then we'll bring all of the y's to one side and all of the x's to the other. Now we can just integrate both sides, so that gives us ln of y (6x) plus c. And then we can put things in terms of y, so we have constant times e to the power of 6x equals y. And now, with the initial value y0 equals 3, we can plug that in. So 3 equals c times e to the 6 times 0, or 3 equals c. So now we know that our differential equation is y equals 3 times e to the 6x. A population of immortal bunnies doubles every 3 months. Write an equation that models their population. At the beginning of time, there are 2 bunnies. So there are 2 ways to do this. The first way is to make our equation something in the form p equals a e to the rt. If we were to do it this way, then we know that the time it takes to double is equal to the ln of 2 over r. So in order to find r, we'll take the ln of 2 and divide it by the time it takes to double, which is, in this case, 3 months. And we're going to be measuring t in months. Okay, and so now we can just write p equals a, and a is the initial amount of bunnies, so we'll replace that with 2. Then we have e to the power of r t. And now we have it in the form that we wanted in the beginning. But if we look at this, we can simplify it a bit. We can write this as 2 times e to the power of the ln of 2 to the power of 1/3 times t. And then e to the power of ln of 2 is just 2, so that gives us 2 to the power of t over 3. In other words, we can also write our population model as p equals 2 times 2 to the power of t over 3. In a population of bunnies, there is a contagious disease. The more bunnies in the population, the faster the disease spreads, so that the decrease in population equals 4 times the number of bunnies alive. How long does it take half the bunnies to die? Okay, so for this, we're going to have to write a differential equation to model what we have. Let's use p as the population. So dp dt is the change in the population, and it says that it's equal to 4 times the number of bunnies alive. So that would be 4 times the current population. But since this is a decrease in population, we have to add in a negative sign. Now at this point, we can solve our equation. So dp over p equals negative 4 dt. ln of p equals negative 4 t plus c. And so we end up with p equals a different constant, c, times e to the power of negative 4t. Now we want to know how long it takes half the bunnies to die. It doesn't matter that we don't know what c is, because the time it takes for half the bunnies to die only depends on our rate, r. And so our half-life is equal to the ln of 2 over 4. Or about 0.173, meaning in 0.173 time units, half the bunnies will be dead. Penny and Rich both won the lottery for $1,000. Penny spends half and saves the rest, and Rich saves it all. The bank has a 5% interest rate, compounded continually. After 10 years, how much more interest will Rich have accumulated? We can use some equations to model this. So our balance is equal to the initial amount times e to the RT, so this is exponential growth. A for Penny is equal to 500, and A for Rich is equal to 1,000. So when we put this in, balance equals 500 times e to the 0.05 t for Penny, and balance for Rich equals 1,000 times e to the 0.05 t. At this point, if we plug in t equals 10, then what we get is that Penny's balance is about 824.50, and Rich's balance is about 1,649. So how much interest did Penny earn? Penny's interest is 824.50 minus 500, or about 324.50. Meanwhile, Rich's interest is about 649. So from this, we can see that Rich accumulated about $324 more of interest than Penny.